Hi, good evening, everyone. So, beta, in today's class, we are going to go ahead and we are going to begin with chapter 6 of Devore. Now, the first thing that we want to go ahead and understand in this chapter is what is called as a point estimator. But before I start with this is something which is for beta semester 2 students, economic honors, Delhi University students. And if you want to go ahead and get these notes that I have written, then you can go ahead and you can download our app from the Play Store and you can write us a message WhatsApp on 83686633950 and you can go ahead and get access to these notes also, right? Sir will add you to this batch of statistics. You can get these notes, right, beta? And at the same time, you can look into these video lectures to understand these concepts. Later, I will also be going ahead and I will be discussing past year paper with you people, right? And of statistics. And we will also be taking some numericals. So it is a good idea that you go ahead and you get yourself added to this batch. Okay, beta, let's start. So first of all, we want to go ahead and we want to understand what is point estimation. See, point means 1 point, huh? 1 point. So a point estimate of any parameter is one number, a single number that can be regarded as a sensible value of that estimate. एक बात समझने की कोशिश करो. फिर से उसी कॉन्सेप्ट पे चलते हैं. See, we have population. ये पूरा पॉपुलेशन तो हमारे डिस्पोजल पे होता नहीं है, पूरी पॉपुलेशन हमारे पास अवेलेबल होती नहीं है. सो बिकॉज पॉपुलेशन इज नॉट अवेलेबल एट अवर डिस्पोजल, क्योंकि ये पूरा पॉपुलेशन हमारे पास नहीं होता है, व्हाट वी गो अहेड एंड डू इज वी वर्क विद द सैंपल. अब अगर मुझे ये जानना है कि पॉपुलेशन का मीन क्या रहा होगा, इफ आई वांट टू अंडरस्टैंड व्हाट इज द मीन ऑफ द पॉपुलेशन, तो इस चीज को एस्टिमेट करने के लिए मुझे सैंपल का कोई एक चीज यूज करना पड़ेगा. आई विल हैव टू यूज समथिंग फ्रॉम द सैंपल. व्हाट आई कैन यूज फ्रॉम द सैंपल, मैं ये बोल सकती हूँ कि सैंपल का मीन निकालो एंड दैट विल गिव यू द क्लोजेस्ट एस्टिमेट अबाउट द पॉपुलेशन मीन. सैंपल का मीन पॉपुलेशन मीन का क्लोजेस्ट चीज होगा. और आई कैन गो एंड टेल यू फाइंड द मीडियन ऑफ द सैंपल and the median of the sample will be the closest thing to the population mean. या मैं बोल सकती हूँ कि trimmed mean निकाल लो. I will talk about trimmed mean in a while, and that will be closest to the population mean. So what I can go ahead and do, I can go ahead and give you different things, but these are called as statics. So I can ask you to find out different statics, and I can ask you कि ठीक है, ये बताओ कि इनमें से शायद कोई एक बेस्ट बताएगा कि पॉपुलेशन का मीन क्या रहा होगा. सैंपल मीन और सैंपल मीडियन और ट्रिम्ड मीन. वन ऑफ दीज विल डेफिनेटली बी क्लोजेस्ट टू द पॉपुलेशन. ये इनमें से कोई एक वैल्यू, वन सिंगल वैल्यू, राइट? सो बेसिकली व्हाट इज हैपनिंग इज, व्हाट इज अ पॉइंट एस्टिमेट? क्या होता है पॉइंट एस्टिमेट? अ पॉइंट एस्टिमेट ऑफ एनी पैरामीटर. बेटा when we talk about parameter का क्या मतलब है? What are we referring to? Population. So point estimate of any parameter. Parameter माने कि हम बात कर रहे हैं population की, is a single number. तो हमें population की वैल्यू को जानना है. यहाँ पे we need to know the mean of the population. We need to know the variance of the population. We need to know the standard deviation of the population. तो हमें जानना है, we need to get more information about the population. और वो information हमें कैसे पानी है? We need to get that information using a single number that can be regarded as sensible value of theta. ऐसा कोई नंबर हमें ढूंढना है जो इसके लिए एक sensible value हो. It should be a sensible value of theta. Am I clear with this? Okay, बेटा. अब थोड़ा सा हम आगे बढ़ते हैं. The question is how to find this sensible value. मुझे कैसे पता चलेगा? How will I know कि इस population के mean को ना sample के mean से निकालो? या पॉपुलेशन के मीन को ना सैंपल के मीडियन से निकालो, या पॉपुलेशन के मीन को ट्रिम्ड मीन से निकालो. हाउ विल आई गो अहेड एंड हाउ विल आई नो व्हाट इज अ सूटेबल वैल्यू? सूटेबल क्या है मेरे लिए, सेंसिबल क्या है मेरे लिए? हाउ विल आई गो अहेड एंड हाउ विल आई फाइंड दैट थिंग, दैट व्हाट इज सेंसिबल फॉर मी, right? So the answer to this is that we can use a method to find out the sensible value. हम एक तरीका यूज कर सकते हैं sensible value निकालने का. And in order to go ahead and in order to understand this thing, I will go towards one example that is given in your book, beta. So I am going ahead towards example number 6.1. ठीक है, ये क्या बोलते हैं? It says that there is an automobile manufacturer and he has developed a new type of bumper. उसने एक बम्पर बनाया है, right? And it is supposed to absorb the impact with less damage than the previous bumper. तो आज तक के कार के कुछ बम्पर होते थे और ये बोल रहा है कि ये जो न्यू बम्पर बनाया है मैंने कार के लिए, whatever new bumper I have created, then this will go ahead and it will touch anything, the damage will be comparatively less, right? Now, in order to go ahead and in order to test this thing, what he is going ahead and doing, he is going ahead and he is testing 25 cars that have these bumpers, right? And what he has gone ahead and what he has seen, he has gone ahead and he has seen कि कितने so 25 कार्स उसने देखे हैं और उसमें उसको ये देखना है कि कितनी कार्स में जो क्रैश हुआ है, that crash has done no damage. उस क्रैश में कोई भी डैमेज नहीं हुआ और कितनी कार्स है जिसमें कोई डैमेज हुआ है, हाउ मेनी कार्स हैव एक्चुअली हैड अ डैमेज. सो ही नीड टू फाइंड आउट दैट प्रपोर्शन. ठीक है, सो द क्वेश्चन इज हाउ विल ही एस्टिमेट दैट प्रपोर्शन. वो उस प्रपोर्शन को कैसे एस्टिमेट करेगा, व्हाट विल बी द बेस्ट वे. So he has found out that there was no damage in 15 cars and there was damage in 10 of the cars. So in order to find the estimate of P hat, where P hat represents the proportion of non-damaged cars in a crash, the claim is कि ये जो P hat है ना, this is simply going to be number of cars with no damage divided by the total number of cars. That means it should be 15 by 25. That means 0.60. And we are saying that this will be a good point estimate of the population. It will be a good point estimate of the population. माने इसका मतलब ये है, this means that in the future if I roll out the cars on road, अगर मैं रोड पे ये कार्स को लॉन्च कर देती हूँ, if I launch these cars on road, then 60% of the cars, जितना भी मैं population में cars launch कर दूँ, 60% of these cars will have no damage after a crash and 40% will have damage after a crash. This is I'm talking about the population. And how am I getting this estimate about the population? मैं कैसे जान पा रही हूँ population से related value? I am able to go ahead and get an estimate about the population based on the sample. So sample में when I had taken 25 cars, 15 cars had no damage. So based on that sample, I am going ahead and generating this information. Am I clear? Okay, beta. So this is, therefore we can say that this is a point estimate of this. So we are saying P hat is point estimate of P. P hat is a point estimate of P, right? Okay, beta. Now let's go to the next example. So in next example, what they have done is they have gone ahead and they have given you 20 observations, right? And in these 20 observations, they have given you some number 24.46, 25.61, ऐसे करके 20 observation दिए हुए हैं. And it says just assume that this is the voltage for something. किसी चीज का voltage आपको given है. Now the question is that, you know, what are the different kind of estimators that I can use, right? मैं इसका मेरे को इस population का mean जानना है. I want to know the mean of the population. The question is, what are the different ways of finding the mean of the population and what will be the closest value to the mean? किस तरीके से निकाला जाए कि मेरे को population के mean से closest value मिले? I want to get as close to the population as possible. This is what my task is. So in order to go ahead and get a value as close to the population as possible, जो हमारा first, the first method that we have gone ahead and we have applied. Okay, I haven't written anything here. Let me just create some space here itself. Okay, so the first thing that the book asks us to do is to find out the mean of the sample. So this is my sample. The sample has 20 observation and I try to go ahead and create the mean of the sample. So when I find the mean of the sample is summation x by n, which is going to be giving me the value of 27.793. So when I go ahead and I find out the mean of these 20 observations, I add all these observations together and I divide it by 20, I will get the answer as 27.793. Now, the second thing that I can go ahead and do is I can find the median, right? And because there are 20 observations, so I know that if I were to go ahead and find the median in this case, it is going to be what, beta? It will be n by 2th observation plus n by 2 plus 1th observation divided by 2. So if I use this method and I try to find the median, I am getting the median as 27.96. Another thing that you can go ahead and do is sample का आप क्या निकाल सकते हो? You can go ahead and you can find out the min value of the sample, the max value of the sample and divided by 2. मतलब आपने दो extreme values ली और उनका average निकाल लिया. So when you do min plus max by 2, then also you're getting the answer is 27.670. And the last thing that you can go ahead and do is you can find the trimmed mean of the sample. So when you try to find out the trimmed mean of the sample, what we do is we arrange the sample in ascending order from smallest to lowest value. And suppose 20% ka beta, what is 20 ka 10%? So I have 20 observation. And if I find out 10% of 20, I will get 2. So I remove the first 2 observation. I remove the last 2 observation and remaining 80% of the observation ka, I find out the mean. Right? Remaining 80%, in this case, 16 observations ka, I go ahead and I find the mean. So when I go ahead and I do that, then in this case, I am getting that the trimmed mean is going to be 27.838. ये मेरा trimmed mean आ रहा है. Now listen very carefully, okay, what we want to do in this case. So we are going ahead and we are getting different values and all these values are called as the measure of central tendency. चाहे मैं mean निकालूं, median निकालूं, mode निकालूं, extreme average निकालूं या trimmed mean निकालूं, all of these are different ways to find out the center. एक तरीके से हम sample का center निकाल रहे हैं, right? And we know that all of these, because they ultimately tell me that these are the sample centers, मेरा क्वेश्चन ये है कि इनमें से कौन सी वो वैल्यू होगी which will be closest to the value of the mean of the population. Because whichever value will be the closest, जो भी closest होगी, that will be actually called as the point estimator of the population. So this is the question I want to go ahead and ask. I want to ask which is that value? कौन सी वो value है which is closest to the mean of the population? Clear? तो अब हम क्या देखते हैं? What do we find out in this case? We, in order to go ahead and answer this question, find out that we must know the mean of the population. हम ये तब निकाल पाएंगे अगर हमें population का mean पता हो. But would I know the mean of the population? Answer is no. Population is not at my disposal. तो अगर population मेरे हाथ में ही नहीं है, if I don't have population, how will I find the mean of the population? I can't do that. Right? So this is what I have gone ahead and I have written here. That number one issue is I don't know what the mean of the population is. And if I don't know the mean of the population, how will I go ahead and how will I ask that whether the mean of the sample or the median or this extreme value average or the trimmed mean, which of them is closest to the mean of the population? ये बात मुझे कैसे पता चलेगी? How will I go ahead and do that? That's the first thing. Second issue, beta. So this is the first issue, that we don't know the value of the population. अब दूसरी issue पे चलते हैं. So try to understand that you have a population. But beta, in the last few lectures, हमें ये बात में समझ में आ गई है that sample is a random variable. What does it mean that sample is a random variable? It means that if person 1 goes to the population and gets a sample of 20 observations, and person 2 goes to the population and gets a sample of 20 observation, तो ये दोनों sample same नहीं होंगे. These two samples will not be the same. So if these two sample will not be the same, तो ये जो sample का mean, median, this average sample here or trimmed mean, ये भी तो sample to sample differ करेंगे. These will also differ from sample to sample. So there is a chance that you can go ahead and you can commit something which is known as an error. What is an error? क्या है error? Error of estimation is basically the error you are committing because the value that you have estimated, it differs from the value of the population. तो जो वैल्यू मैं एस्टिमेट कर रही हूं यूजिंग अ सैंपल, चाहे मैं सैंपल 1 यूज करके कुछ मीन निकालूं या 2 यूज करके या n यूज करके, the value that I am estimating using a sample, it will be around the value of the population. Population के मीन के आसपास ही होगा सैंपल का मीन. It will be around the value of the population, but at the same time, it will have some variation. कुछ variation तो रहेगा. It will not be exactly equal to the value of the population. और उसी को हम बोल देते हैं error of estimation. That becomes the error of estimation. So we are saying theta hat. Theta hat is the value of the sample. The value of the sample will be very close to the value of the population, but I will be committing an error. And as a statistician, मेरा क्या काम होना चाहिए? What should be my aim? What should I be doing? I should be going ahead and I should be minimizing this. I want to minimize or lower this error. I want to lower this error. Am I clear with this? So I go ahead and I find out this error beta. What is the error? Error is the difference between what I estimated, the sample value, and the value of the population. Now, we have to understand that sometimes the error can be negative, sometimes the error can be positive, and overall this can sum up to 0. कभी कभी error negative होगा, कभी कभी error positive होगा, और उनका sum बहुत बारी 0 भी हो सकता है. माने it may be possible कि sample 1 का जो हमारा mean है मैंने निकाला 20, हाँ, and जो population का value था वो था 18. So जो मैंने error किया that was 18 minus 20, that means -2. और sample 2 में जब मैंने mean निकाला that was 21. Population का value mean था 18, not 21, say 16. और जो मेरा error हुआ that is 18 minus 16, that means +2. So if I just sum up these errors together, अगर मैं ये सारे errors को add कर दूं, some errors positive across different samples, तो मेरा error ऐसा हो सकता है ना that will become 0. I want to avoid this issue. मुझे ये issue नहीं चाहिए that the sum of the error is 0. So what we will do in this case, we will not work with the sum of the error terms. Rather, we will go ahead and we will work with something which is known as mean of the square of the error, mean square error term. So our aim is to go ahead and minimize the mean. Mean means expected value of the square of the error term. So we will first square this error term. Then we will go ahead and find its expected value. And we will want to go ahead and minimize this thing. We want to minimize this thing. Right? Clear है? अच्छा, अब मेरी बात सुनो. So we said theta is the parameter of the population. Right? Suppose currently जो मेरे दिमाग में चल रहा है parameter, let's say that parameter is the mean of the population. I want to estimate the closest value of the mean of the population. अब इसको estimate करने के लिए I go to the sample. Now the question is, should I estimate it using the mean of the sample? Should I estimate it using the median of the sample? Should I estimate it using the mode of the sample? Should I estimate it using the trimmed mean of the sample? Should I estimate it using the extreme average sample? किससे इसको estimate किया जाए? सब ये θ1 hat बोल देते हैं इसको θ2 hat बोल देते हैं, θ3 hat, θ4 hat, θ5 hat. ये अलग-अलग थीटास हैं. These are coming from the sample. But which of them is the best estimator for this population? इस population के लिए best कौन सा रहेगा? What one should I use? So I have to use that criteria. I will be using that estimator which goes ahead and minimizes the mean square error. That is why this is important to understand. जो mean square error को minimize करे, जो mean square error को सबसे कम कर दे, मुझे वही वाला statistic use करना है. I need to pick that from the sample. मुझे वो वाली चीज sample की निकालनी है. Now, beta, what I want to go ahead and emphasize now is that we want to additionally satisfy two properties. हमें जो भी हम estimator choose कर रहे हैं sample का, उसमें हमें दो properties को satisfy करना जरूरी है. We need to satisfy two properties. And in today's class, I will be focusing on the first property, which is known as unbiasedness. The property of unbiasedness says that if you go ahead and you find the expected value of the statistic, जो आपका स्टैटिस्टिक है, जो थीटा हैट है, जो आपने सैंपल से वैल्यू निकाली है, अगर आप उसका मीन निकालो, इट शुड बी इक्वल टू द वैल्यू ऑफ द पॉपुलेशन. और बेटा ये हमने चैप्टर नंबर 5 में वी हैव स्टडीड दिस थिंग कि जब हम मीन ऑफ द मीन निकालते हैं, मतलब हम अलग अलग सैंपल लेते हैं. इसका सैंपल मीन है x1 बार, x2 बार, x2, x3 बार, x4 बार. एंड इफ यू रिमेंबर इन चैप्टर 5 हमने इसका प्रोबेबिलिटी डिस्ट्रीब्यूशन बनाया था. सो वी सेड कि ठीक है, x1 बार होने का प्रोबेबिलिटी कितना, x2 बार होने का प्रोबेबिलिटी कितना, x3 बार होने का प्रोबेबिलिटी कितना, x4 बार होने का प्रोबेबिलिटी कितना. So we had gone ahead and we had prepared this probability distribution function. हमने ये PDF बनाया था. And from here, we had gone ahead and we had found the mean of the sample. So if you remember, we have already shown, and I had given you a homework question on this also from the exercise. We have already shown that the expected value of the mean will be equal to the mean of the population. अगर हम सैंपल मीन का एक्सपेक्टेड वैल्यू निकालेंगे तो वो पॉपुलेशन मीन के बराबर होगा. सो आउट ऑफ ऑल दीज थिंग्स दैट वी हैड इन माइंड कि क्या सैंपल मीन यूज करें, मीडियन यूज करें, मोड यूज करें, ट्रिम मीन यूज करें, एवरेज यूज करें, क्या यूज करें, उसका आंसर का पहला पार्ट ही ये हो गया दैट सैंपल मीन will be an unbiased estimator of the population. Population का वो एक unbiased estimator रहेगा. Am I clear with it? Okay. Now, suppose there is some kind of bias. अगर हम ये माने कि जो हमारी sample mean की expected value आई है, whatever expected value I have found out for my sample mean, if we find out that that is not equal to the population mean, right? The two values are different. Then the difference between the population mean and the average of the sample mean, this is called as the bias. This gap between the sample mean and the population mean, this gap is called as the bias. इसको हम क्या बोल देते हैं? Bias. Am I clear with it? Okay, beta. So this is two examples that I want to take in today's class. Example number 1 and example number 2. You can go ahead and refer to your book again. And in your book, you will notice that this is figure 6.1. ठीक है, अब ध्यान से देखो बेटा. These two distributions are symmetric, normally distributed distribution. ये symmetric भी हैं और normally distributed भी हैं. So these are symmetric and normally distributed distribution. अगर आप देखो तो ये थीटा 1 का पीडीएफ है और ये थीटा 2 का पीडीएफ है. You need to realize that here the expected value of theta 2 is exactly theta. अगर मैं इसका expected value निकालूं तो that is coming as exactly theta. Whereas you will realize that the expected value of theta 1 hat, that is coming as some other value, say theta dash. Right? So you will notice that the expected value of theta 2 hat is coming as theta, और थीटा पॉपुलेशन का वैल्यू था और ये सैंपल का स्टैटिस्टिक है एंड दिस इज पॉपुलेशन पैरामीटर. So we are noticing that the expected value of the population statistic is population parameter, expected value of the statistic is equal to that of population. So we can go ahead and say that it is unbiased. So theta 2 hat is unbiased estimator of theta. अब यहां देखो थीटा 1 hat का जो एक्सपेक्टेड वैल्यू आ रहा है दैट इज कमिंग एज थीटा बार एंड थीटा बार और थीटा में गैप है, राइट? दिस इज नॉट इक्वल टू थीटा. थीटा पॉपुलेशन का वैल्यू है. दिस इज कमिंग एज द एक्सपेक्टेड वैल्यू फ्रॉम द सैंपल स्टैटिस्टिक. तो इन दो का जो गैप है दिस बेसिकली बिकम्स माय बायस. दिस इज बेसिकली माय बायस. Okay, अब example number 2 देखते हैं बच्चे. So now my distributions are skewed distributions. तो skewed distribution में क्या होता है ना, that if you have a distribution like this, if you have a skewed distribution, तो the mean of the distribution can be here. जरूरी नहीं है that mean will be at peak. That is only for symmetric distribution. So now I have taken the two distribution to be the skewed distribution. ये थीटा 2 hat का डिस्ट्रीब्यूशन है, थीटा 1 hat का skewed डिस्ट्रीब्यूशन है. These are skewed distributions. And this is coming as the expected value of theta 1 hat, theta 2 hat. Theta 2 hat का ये वाले डिस्ट्रीब्यूशन का जो expected value है that is coming here only. And it is actually equal to the value of the population parameter. It's equal to the value of the population parameter. So क्योंकि expected value of theta 2 hat, it is coming equal to theta, therefore we can go ahead and say that this is unbiased. But जब हम theta 1 hat की बात करते हैं, when we talk about theta 1 hat, then we actually go ahead and realize that its mean value is falling here. Whereas we notice that the value of theta is here. तो इसका expected value is here, theta 1 hat का, and population parameter is here. So this is the amount of bias that has been generated. This is the amount of bias that has been generated. So I hope this is clear to you. We are discussing the first property beta of parameter, and this is known as the property of unbiasedness. And there is unbiasedness when you have expected value of the parameter exactly equal to the value of the population. And if there is biasness, expected value of the statistic is not equal to value of the population, and the gap between these two, that actually accounts for bias, right? Okay, so this is one last table that you need to go ahead and you need to remember. But a population mean का unbiased estimator sample mean होता है always And population mean का so sample mean is always the unbiased estimator of population mean. But along with sample mean, the trimmed mean and the median are also unbiased estimator of population mean if the distribution is continuous and symmetric. So because in symmetric distribution, mean, median, mode are equal to each other. So even these two become unbiased estimator of the population mean. And not only that, the trimmed mean is also an unbiased estimator of the population mean in this case. Okay, now let's talk about the variance. So when we talk about the variance, please remember that sample variance is unbiased estimator of the population variance, but the formula of sample variance is when you divide it with n minus 1, not by n. So the formula of unbiased estimator of sigma square is summation xi minus x bar whole square divided by n minus 1 and not n. Am I clear with it? So this is an unbiased estimator of the variance of the population. Okay, beta. Okay, so that's it for today. We will go ahead and continue it in the next class. Thank you, beta.